Okay, good morning to everyone. In the previous class, we were discussing about the different zones. The first zone is zone of degradation. Second one is zone of decomposition, zone of recovery, and the clear zone. Always you have to explain with that figure only. The figure which I showed, that is this curve. In this only you divide what will be the zone of degradation, what is the zone of decomposition, and what is the zone of recovery, and it's a clear zone. So then we'll move on to suppose how exactly the BOD or any of the mixture can be calculated. For example, um, you take the river. So assume that the wastewater is mixing, which is having the BOD of at starting BOD. Assume that it is 500 milligram per liter. 500 milligram per liter. Suppose at the initially it is 500 milligram per liter. Suppose when it come and it will mix with this water portion, then how much the BOD is going to happen at this point? Suppose if I want to find out that, then we have to use this formula. So that is the BOD of the mixture at this point can be calculated with the help of this. So that is L at the outfall. L, no, it's the outfall. It is not zero. It is outfall. Outfall means I already said that at this point, whenever it is going to mix. So then it is QR LR plus QW LW divided by QR plus QW, means where L naught or the L outfall is the ultimate BOD of the waste, ultimate BOD at point of waste discharge. QR is flow in upstream of the discharge, and LR is ultimate BOD of the river water, or QW is the flow of wastewater from the discharge, and LW ultimate BOD of the discharge wastewater. So here you can say it is for QR is for the river and it is for the wastewater. Quantity of flow for the wastewater and the quantity of flow for the river. Then this is the BOD of the river and the BOD of the wastewater. Assume that in this, whatever it is flowing like this, assume that is a LR and this is a QR, and this is for the wastewater, this is LW and QW. Suppose if you want to find out the mixture, that is L outfall here, so we have to use this formula. So here QR stands for quantity of flow or the flow of the river, then it is a BOD of the river, then flow of the wastewater and the BOD of the wastewater, divided by combining of the flow of river as well as the wastewater. So then if you take an example, the wastewater of the effluent is having 600 liters per second. So this is the effluents. Okay. Then with a BOD of 60 and a DO of 2.5 milligram per, and the temperature of 25 degree, enters the river where the flow is 30 meter cube per second, and BOD of 3 milligram per liter, DO of 8.5 milligram per liter, and temperature of 600 degrees centigrade. Deoxygenation constant for the waste is 0.1 per day at 20 degrees centigrade. The velocity of the water in the river of the downstream, that is 0.15 meter per second, and the depth of flow is 1.5 meter. So determine the following after mixing a wastewater with the river water, that's combined discharge, BOD, DO, and temperature. So here you have to make two classifications. So first one is for the wastewater. Second is for river. So what are the things are given for the river and what are the things for given for the wastewater discharge? So first one, so starting with the effluent. The effluent means you can consider this as effluent. This as a effluent. So effluent is having flow, that is Q of QW. We can call it as wastewater QW. How much they have given? 600 liters per second. Then BOD, that is LW. How much they have given? 60 milligram per liter. Then DO of W. DO of W. We can call it as a DO of this effluent, that is 2.5 milligram per liter. Can make like this. Then temperature of the wastewater. So that is equal to 25. Similarly, 25 degrees centigrade. Similarly, for the river, the flow is, that is QR, that is equal to 30 meter cube per second. Then LR, that is BOD, that is 3 milligram per liter. Then DO, that is 8.5 milligram per liter. This is for the river. Then temperature of the river, that is equal to 16. So these things they have given, and here two constants are there. One is deoxygenation constant, that is usually divided by K. Then reoxygenation constant, that we already, deoxygenation and reoxygenation we already discussed. Deoxygenation, that is given by normally R. Reoxygenation constant is given by R and deoxygenation constant is given by K. Here he has given the deoxygenation constant, that is 0.1. So these two constants are with respect to deoxygenation or the reoxygenation. Then the velocity of the flow, that is 0.15 meter per second, and they have given the depth also. Depth, that is equal to depth of flow, that is total depth of flow is 1.5 meter. So then if I want to find out the combined wastewater, so always first thing is that you have to convert this into either this you have to convert this into liter per second, or this you have to convert it into meter cube per second. So it is better you have to convert this into meter cube per second, that is 600 meter cube per second. Liter per second is there. So if you make it 5000, you will get it 0.6 meter cube per second, because we have 1 meter cube is equal to 1000 liters. So then the combined discharge, that is QR plus QE. QE, what I am taken here is that instead of QE I am taken here QW, because I explained in the previous formula, that is with a QW. Here now you assume that it is wherever QW is equal to QE. That is a effluent. Then if I want to find out the BOD of the mix, so then I have to use that formula QR LR plus QW, LW divided by QR plus QW. With that formula, if you use it, so you will get it. So L at outfall, that we already did, QR LR plus QW LW divided by QR plus QW. This formula I have to use it. So similarly for DO mix also, in place of LR we have to use the DO mix here. So DO of mix, So I have to use QR into, that is a DO of the river plus QW to DO of wastewater divided by QR plus QW. Similarly, for temperature also, you have to use the same formula. So that is temperature of the mix is equal to QR into temperature of the river plus QW, then temperature of the wastewater divided by, whole divided by uh, QR plus QW. So then we'll get the combined temperatures. This is one problem. The remaining related to the sewage forming, we will discuss in the next class, the sewage thickness and the state of health equation. And later also we'll discuss some of the, next we'll go ahead with the treatment of wastewater. Of course, this problem is very easy, but with respect to this, they may ask any question also. In this problem, only he has asked what will be the combined discharge, combined DO, and combined temperature. But in the further, he might twist the problem also. In that cases, should be very careful. So along with this information, we will solve or we will try to recall this state of health equation. That is very important uh, as the competitive examination point of view. Of course, in your examination, he may ask the problems based on state of health equation, or they will restrict to only this much problem only. Um, but in the competitive exams, that state of health equation is very important and it is required also. The remaining portion we will cover in the next class.